So what we're going to look at in this series of lessons, we're going to look at the scientific method and how do scientists work. So this is something that's important in the current syllabus of the junior certificate science. It's important to know like how scientists work and the scientific method, if you like. So I'm going to go through Galileo. So Galileo is really considered, if you like, the grandfather of science. So using Galileo's story, I want to kind of emphasize just like a very important learning outcome um, for this section of the science syllabus. So students should be able to appreciate how scientists work and how scientific ideas are modified over time. So we look at Galileo's example to kind of give you an insight into this particular area. Okay, so Galileo. So this is a portrait of Galileo. So Galileo existed and did his thing around, you know, in the the 1560s and 1564 to 1642. Okay, so around that time. He was from Pisa, so he was an Italian. He was an Italian astronomer, physicist, engineer, and sometimes described as a polymath. Okay, so he was a very gifted and very inquisitive, and he was interested in a lot of different areas and a lot of different topics. And that was something that kind of got him into a little bit of bother during this particular time. So bear in mind, during this time, around this time here, the church had massive influence all over the world, and the Bible was, you know, a source of information that was taken very, very seriously by the people that were around at that time. So people that spoke against the Bible could easily find themselves being burned at the stake for heresy. So it was a very, very different time to the times that we live in now. And this was kind of, if you like, Galileo kind of started this scientific method, and he was very observant. And there was particular ideas that were in place at the time. So one idea, for example, was that all of the planets everything revolves around the Earth, and that humans are the center of the universe. Earth is the center of the universe, and everything goes around it. Okay, now this is proven to be incorrect, but at that time, this belief was very strong and held in place, and it was backed up, if you like, by the Bible. So, for example, God was perfect, and God made humans who are perfect, and God made the earth and all of the planets and the orbs that are in the sky, like the moon and the sun, which are also perfect as well. So, like almost everyone in 16th century Italy, where Galileo was born, Galileo was taught that Earth was the center of the universe and that other heavenly bodies were smooth, shining spheres, perfect examples of God's creation. So, this was the kind of very held fast belief during this time when Galileo was about. According to the church, any other belief would be contrary to what it said in the Bible and therefore heresy. Okay, so this was something that was a big deal at the time. If you contradicted or spoke against the church or the Bible, you could find yourself in a very difficult situation indeed. So again, this idea that was held in place was that the earth was the center point, and then everything revolved around the center point. Okay, so this was a belief that was held in place at the time, and this kind of supported this idea that humans were, if you like, made in the image of God, and that they were divine creatures, if you like, and that we were the center point of everything. The other kind of things that they talked about as well was that the heavenly spheres. So when we talk about heavenly bodies, like we're talking about the moon and the sun, for example. So people looked at the moon and said it's a perfect sphere, and this again, highlights how perfect God is, and how perfect the Bible is, and how perfect creation is. So again, kind of the emphasis would be that, the heavenly bodies, like the moon, for example, like it was smooth, they were shining spheres, perfect examples of God's creation. So this is like the idea, if you like, that was in place at this time when Galileo was about and he was doing his thing. Now, Galileo, being a good scientist and being very observant and very interested in looking at the world around him and trying to use logic to make sense of everything, he was very interested in what was going on around him. At the time, glass, being able to make lenses was relatively new at that time. So there were telescopes, but they were very kind of crude instruments, and not everybody could afford a telescope, and not like today. But at that time, like, telescopes enabled the person that was using these scopes to be able to look a little bit further and see things with a little bit more detail. And this is what started to, if you like, get Galileo into trouble. So he was very observant, he was very interested in looking at the world around him. And a big thing he used to do, he was an astronomer, he used to spend time looking at the sky and studying these heavenly bodies that were in the sky, and not looking at them in detail. Now, so when Galileo got his hands on these telescopes and he started looking at these heavenly bodies in the sky with a bit more scrutiny and a bit more detail, it started to kind of poke holes in the idea that the church was putting forward at the time. That these heavenly orbs, if you like, were perfect. So however, when Galileo used his telescope to study the moon, he observed no smoothness, but what looked like mountains and valleys. Okay, so this is something that he started to look at, started to notice this detail when he started to look at the moon under the telescope. So by focusing on the boundaries between the dark parts of the moon and the areas lit by the sun, where shadows were longest, and measuring the shadows there, he could calculate the height of some of the mountains. So when he started to look at this moon, for example, he started to notice that it was, in some ways similar to the Earth. He started to notice it wasn't a smooth body. There was lots of ridges. There was even like mountains and mountain ranges and all kinds of detail that, if you like, contradict what the church was saying at the time. And he was even able to, using his keen intellect and using maths and looking at what he was seeing, he was even able to kind of calculate some of the heights of these mountains that he was observing with his microscope or with his telescope on the moon. So he realized that the surface of the moon was very jagged and rocky, and he also thought that the dark, smoother spots on the moon indicated seas. Now think about it, at that time, before Galileo was able to look through the telescope and see a little bit more detail, if you look up at the moon now, there's not a huge amount of detail that you can see on the moon. Okay, so you can, next time there's a full moon, go out and have a look at it. So there's certain things you can see on the moon, but by no way can you make out the detail that you can if you look at the moon under using a telescope. So all these observations went right against current concepts about the moon, and they supported the forbidden belief that there were other worlds like Earth, and a belief for which Bruno, okay, so it was another guy that was alive during this time, had been convicted and burnt to death. Okay, so this is how serious it was for people to speak against the church and speak against what was written in the Bible. You could be labeled as a heretic and be burnt to death. So this is Galileo here, and you can see he's like a portrait of him looking at the heavenly bodies or the moon, practicing astronomy at the time. This here is an image taken from the moon, and we can actually see now, like with modern technology, we can see that it's the moon is in some ways has similar features to the Earth in that it's jagged, it has mountains, it has craters, it's in by no way smooth and perfect. So this was Galileo's telescope at the time. It was very, very crude setup. So this is kind of the way that it looks. So you just had simple telescope, light passed through it. It was focused at a point, and then you could look at this and you would see magnification of your whatever it was that you're looking at. In this case, Galileo would have been looking at the moon. So the moons of Jupiter. Not only was Galileo looking at he was kind of looking at the moon and seeing that, like, what he was seeing under the telescope, using the telescope, was contradicting what was written in the Bible, for example, and what the church was saying at the time. Also, as well, he started to look at so these are the moons of Jupiter. So as Galileo improved his telescope, so he kept improving on the telescope and it kept getting better and better, he was able to observe Jupiter. Okay, so this is Jupiter here. He determined that the four stars that moved with it could not be fixed stars, but were four moons. So he started to look at, like, observing how these they thought they were stars at the time, like how they changed in relation to the planet itself, Jupiter. And he determined that the four stars that moved with it could not be fixed stars, but were actually four moons. Okay, and what they also indicate is that these moons would orbit Jupiter. So he quickly published. So what he was starting to see all of these findings. He was excited about it, and he wanted to do what all scientists do: write down their ideas and publish their ideas to see what other scientists think. So he quickly published his findings, but his ideas were not easily accepted. Few people could obtain or use the high quality lenses Galileo had made to see the shadows on the moon. So again, like, lenses weren't as readily available as they are today back in those times, or the moons of Jupiter. Experts in other countries, without Galileo's good telescopes, rejected his theories. They weren't able to see the same things that he was able to see, with the good, lenses that he had. And people were very reluctant to change their ideas about the moon. It was part of God's heaven, so it must be smooth and perfect. Some astronomers came up with alternative suggestions. For example, the moon had an invisible crystal outer layer that was perfectly smooth, but Galileo scorned their convenient theories. So again, people don't like their ideas being challenged. So Galileo was saying, maybe the moon isn't as perfect as it's been, being made out to be. I can see, all of these imperfections on the moon. He published his ideas. Other people were not accepting, like, what he was saying. So it shows how certain ideas are slowly starting to change, slowly starting to be changed. So Johannes Kepler, who's this guy here, he was one well-known European astronomer and mathematician. So Johannes Kepler thought Galileo was on the right track. So Kepler borrowed a good quality telescope and confirmed Galileo's measurements of the revolution of Jupiter's moons. Galileo shared some further discoveries with Kepler, but he used a secret code to ensure that Kepler couldn't claim the ideas as his own. One of Galileo's new discoveries gave good evidence that Venus orbited the Sun, not the Earth, as had been previously thought. And this supported the idea of Copernicus, but at a meeting of the Inquisition, Galileo was ordered not to teach Copernicus the sun-centered theories, but to think of them as imaginative ideas, not absolute truths. So the church also decided to alter Copernicus's book to reduce the possible damage it might have on people's faith in the Bible. So here you had kind of, the early remnants of science. So you had Kepler and you had Galileo starting to work together and starting to confirm some of these observations that Galileo was making with the new technology at the time, with the lenses. And again, these new revelations were kind of poking holes in the Bible, and the church at the time were afraid of losing the people, so they kind of stepped in. So the big kind of debate at the time was these two ideas here. So at the time, the church kind of promoted this idea that the Earth was the centerpiece and everything revolved around the Earth. All of the other stars and planets that could be observed in the sky, they orbited around the Earth. And what Kepler and Galileo kind of started to develop was this idea here, was that the sun was actually the center point in the solar system, in our solar system now, and then that all of the other planets, including our own, orbited around the sun. So by observing and by working with, by looking at the moons, for example, that orbited Venus that can be observed from the Earth, they were able to work out and figure out that, well, actually, it looks like this model here is much more likely than this model here that was being purported at the time. And this was a big problem for the church, okay, because it started to indicate that, okay, maybe the Bible isn't as perfect as it's being made out to be, and it started to poke holes in what was being taught at the time, and largely coming from the church, for example, what was being taught. So again, the church were afraid that they're going to lose people over to this new kind of, making observations and coming up with theories based on observations. So again, we can see how this Earth-centered idea is starting to shift over time, okay, and it's starting to shift over to more of this idea. And this here is what's been proven now in modern times. This is actually what happens. This is not what happens. Even though if you look up at the sky, you can see that the sun moves through the sky, and you could easily can understand why they came up with this particular idea, because it seems that way from our perspective on the Earth. So the Inquisition then, so Galileo's run-in with the Inquisition was a warning to him. Okay, he was a religious man and felt that his discovery showed how marvelous God's creation was. He didn't intend or want to disprove the Bible. That's not what he was about. He actually believed in God himself, and he felt that what he was seeing even highlighted more that there must be a God out there if they're able to create, things like the moon and the planet and the sun. He left Rome to live in Florence, near the convent where his two daughters were nuns. So he was actually a very deeply religious person himself, and worked on safer scientific topics. Okay, so these were kind of topics that were dangerous for him at the time. When a new pope was appointed, Galileo gained permission to write about his theories of the universe. So these theories that we just talked about, but he omitted to mention he'd previously been forbidden. Okay, so he had these theories, and the church didn't agree with them at the time. A new pope came in, kind of, gave him the nod, said, okay, go on ahead, you can work away on your ideas. He wrote dialogues about two world systems, and this is a picture of, this is like the book that he wrote. It's in Italian, and he omitted to mention, so he wrote the dialogue about the two world systems, which came close to mocking the Earth-centered model. Okay, so he wrote this book, and strongly supported the if you like, sun-centered view. This caused major problems. Galileo was tried and convicted for disobeying the church's instruction by teaching Copernicus's views, or this sun-centered approach. So again, you had the Bible at the time, and this is the church, a portrait of the church, if you like, really kind of cracking down on what Galileo was allowed to talk about and what he was allowed to kind of publish based on the observations that he was making with his telescope. So as time went by, so Galileo, he agreed to make a public apology. So even though he was on the right track, and he in ways could, based on the evidence, he felt that he was right, he still kind of fell on his sword and made a public apology. So Galileo agreed to make a public apology and swear that he did not believe the Earth moved around the sun, and not publish any more books about this. He was allowed home after a year to live under house arrest, so he was put under house arrest. And the death of his eldest daughter added to his unhappiness. But gradually he revived, and he began working on new scientific ideas until his death in 1642. And he died at the age of at 78. And this is a portrait of him, making a public apology. Like, he was right, but what he was right about was poking holes, if you like, in the Bible and in the church's influence. So therefore, they didn't like that and they kind of stepped in. So if we think about, so what was the idea and how did it change? So like we're talking about this, how scientific ideas are developed and how they change over time. And Galileo was a scientist. He's considered the grandfather of science. And if we think about like how he worked, and that is the way like that science works. And science is an ever evolving process that tries to get better and better and better. It's not, if you like, a static model. It changes with the times. So ideas of his time. So this is during the times of Galileo. So at the time, the kind of held belief that was, and it was promoted by the church, was believed that the sun moved around the earth. Sorry, that the sun moved around the earth, and that the earth was the center point. Okay, so that was the kind of belief that was being taught at the time. So heavenly bodies such as the moon were smooth, shining spheres, perfect examples of God's creation. So again, that was a kind of common idea at the time, and that there are not other planets or worlds like Earth. Earth is a perfect place created by God. It's one of a kind, and it makes sense. Like if you think about at that time, they didn't have the Hubble telescope. They didn't have the ability to travel like outside the Earth's atmosphere. They were just about had the ability to be able to extend their view with microscopes that were all right but not great. So they were very limited in what they had, like the instruments, if you like, to make their observations. So their ideas were based on these observations that they were making at the time, and it made total sense to them at the time. So Galileo then kind of he started to develop the idea that the Earth moved around the sun and that the sun is the center point. Okay, so you can see how this idea is completely changed. Like we're looking at the movement of the planets and the movement of the planetary bodies and how they move. The surface of the moon was very jagged and rocky and maybe not so perfect. Okay, so that's what he started to notice. And so this forbidden belief that there were other worlds like the earth. So maybe like Galileo started to put this idea in people's heads that the earth is not the center of the universe, that there might be actually other places like the earth. And these were things that kind of these were ideas Galileo was coming to, not based on dogma or not based on like hearsay or what somebody else had said, based on observations that he himself was making and that anybody else could go along and make and test as well. And that's like the basis, if you like, or the bedrock of science. So that kind of gives you an idea. Like Galileo is like a prime example of a scientist and like how scientists work. So like what do scientists do, and like what was Galileo doing at the time? So science really starts off with asking questions. So being interested in the world around you. So Galileo was interested. He had his microscope, his telescope, and he was interested in looking at the world around him. So it starts with asking the question, then it starts with doing some background research. So at the time, Galileo would have read everything available about the moon, read everything available about Jupiter and its moons, read what was the church and what was the Bible and the church's literature, what was it saying about these heavenly bodies. So think about, they would have had loads of time to kind of go outside, look up at the sky and study the stars and the moon and think about what it all meant. So after asking questions and after doing some background research, you're going to construct what's known as a hypothesis. So a hypothesis is, instead of telling people this is the way it is, you say this is the way I think it is. So a hypothesis is, if you like, an educated guess, but it's more than that. It's an answer to a question, or it's a reason for the way things are, or it's basically a question, or like, if you like, a theory that can be put forward, that can be tested. So it's your hypothesis. So what's your idea? What do you think? That's like your hypothesis. So then what you can do then is you can go and you can test your hypothesis with an experiment. So for example, Galileo had a hypothesis that the moon wasn't a perfect sphere. How did he go about testing that? So he went and he carried out he went and done an experiment. He looked at the surface of the moon using a telescope, and he was able to, with just direct observation, see that the moon wasn't this perfect sphere, and he was able to make those observations. Also, as well, he was able to look at the movement of the moons around Jupiter, and he was also able to see, he was able to use that information to kind of make predictions about like the movement, for example, of the planets in the solar system. And not only that, so he made this hypothesis, he came up with this experiment, he came up with ways to observe and use the telescope to make his observations, but he shared this information with other people as well, like Kepler. And they were able to develop some mathematics, and they were able to prove, for example, that his idea was maybe like plausible. Okay, so they don't say, yes, it's 100%, this is the way it is now. They say that, okay, so the idea is fairly plausible. So again, when we get to this kind of stage here, we say, does the idea work or does it not work? Okay, so what you're really looking at is your hypothesis supported? So if your hypothesis is not supported, okay, so if your observations or your experiment has shown that your hypothesis is not correct, you make sure that you've done the test properly, and you might run it again. And again, if it keeps coming back that, look, your idea is not supported, then that idea is, if you like, rejected. Now, what will happen then as well is that if your idea is supported, and if the evidence that you gather supports your idea, you gather all of your data is analyzed, and you're able to draw a conclusion from it. Okay, so your conclusion then is either going to be yes, your idea is supported, or no, your idea is not supported. So the results will either align with the hypothesis, okay, or the results align partially or not at all with the hypothesis. So that's what's going to kind of happen. The information or the observations you make will either support your idea or not support your idea. And sometimes what they can do is they can partially support your idea, and then what you need to do is you need to revisit your initial idea and see, okay, how, like, maybe we have it half right. Maybe we just, like, some part of it is correct, some part of it is not correct. Can we determine, like, what part is correct and what parts are not correct? So that can result in what's known as forming a new hypothesis and doing another experiment. And then what happens then, what's really key with science is that your ideas are not, you don't just keep your ideas to yourself, your ideas are communicated with other scientists. And scientists do this by publishing, they publish papers in journals, and basically these journals are open to scientists all around the world. And at the time of Galileo, he would have written his ideas down, and he would have sent his ideas to other scientists to get them to have a look at the ideas and say, like, ask if they agreed with him or not agreed with him, to kind of see. So the idea with science is that you start off with an idea, and really what you're trying to do is you're trying to prove that it's wrong. Even if you feel that it's right, you're trying to, in every way possible, prove that that idea is wrong. And if you cannot prove that the idea is wrong, then your idea holds a little bit of weight. So it's very different than the way some arguments work. So for example, if you take some of the arguments in the church, for example, they basically say that this is the idea, idea has come from God, and you accept that idea, and it doesn't matter what the evidence says, you accept it based on faith. So again, this was a big change in the way people were thinking and in the way people were developing ideas at the time. So again, I just say, pause the video and take a look down through this and think about, like, each of the steps. So this is what's known as the scientific method, and we're going to come up against this time and time again as we move through the course. So that was Galileo's story, and if we think about, so what we were trying to kind of get from the story was, we're trying to, so at the end of this, really like students should be able to appreciate how scientists work. So if we think about how Galileo worked and how scientific ideas are modified over time. So how this idea of the Earth being the center of the universe has changed over time, and like how it has changed. It's changed by people making observations, coming up with new evidence, and then coming up with new theories and proving them. And basically, that's how science works, and that is the way that scientists work. So thank you for listening.